Welcome to the 1.3 practice problem set. This is Unit 1, Lesson 3, different types of sequences. All right, here are the first two terms of some different arithmetic sequence, -2, 4. Now, you see the word arithmetic. Let's highlight the word arithmetic. Whenever you see the word arithmetic under it or over top of it, write plus, minus. So you have to add or subtract. There's no multiplication here. So now, if we look at it, if you don't know how to get from one term to the next, do 4 minus -2, which equals 4 plus 2, which equals 6. So it's adding 6 going to the right. So now the term is plus 6, so we're going to do 10 plus 6 is 16, plus 6 is 22. Okay, now for the next one. Same thing, 111 minus 11 is 100, so we're adding 100. So 211, 311, 411. Now how do we get from 5 to 7.5? Subtract 7.5 minus 5 is 2.5. So you get 10, you get 12.5, you get 15. And then for the, I forgot to change the colors. My fault, people. And then for the last one, 5, and we get to -4. So it's -4 minus 5. It's always the term on the right minus the term on the left. So the change is -9. So -4 plus -9 is -13. Same signs add. -22. -31. So that was -9. This should have been in green. This was plus 2.5. Whenever you see a sequence, the first thing you do, write the change. All right. Now let's determine whether these could be arithmetic, geometric, or neither. Okay. So to go from 200 to 40, if you ignore the 40, and you go 20 to 4. How do we get from 20 to 4? Well, you could subtract 16, because 4 minus 20 is -16. But 4 minus 16 is -12, so that doesn't work. So 4 divided by 20 is, what, 1/5? So we're multiplying by 1/5. If we're multiplying by 1/5, that makes this geometric. 2 times 2 is 4, times 2 is 8. But this is 2 times 2 times 4. The next one is probably times 6 or times 8. So let's see if we can we add? 2 plus 2 is 4. 4 plus 2 is 6. So that doesn't work. So you cannot multiply or divide to get to the next one. So this term is neither. Because remember, you must have the same term acting, the same operation, the same constant operating on all terms. The next one, we get 10, 20, 30. So this is plus 10. That makes that arithmetic. All right, 120. 10 divided by what is 2? 10 divided by 5 is 2. 20 divided by 5 is 4. So again, we're times 1/5. And it's geometric. And then 6 plus 6 is 12, plus 6 is 18. Okay, so this is arithmetic. So what you want to do is try to add or subtract first, then go ahead and try to multiply and divide. Okay, complete each arithmetic sequence with the missing terms, then state a rate of change. Okay, -3, -2, -1, 0, +1. So the change is +1. So 13 and 25. So 13 plus 12 is 25. So if I add 12, I'm at 37. If I add 12, I'm at 49. If I subtract 12, I'm at 1. So the change is +12 going to the right. So whatever you do going to the right, it's the opposite going left. 1.25. 1 divided by 4 is 0.25. 0.25 divided by 4, 0.25 divided by 4 is, how many times does that go in? 5, because that goes in 0, 20. No, I could have went in 6. 24, I get 106.0625. But see, this number is getting smaller. If I divide by 4, it's getting smaller. That won't get me to -1, so that doesn't work. So I tried dividing. So now I'm going to try to subtract. 0.25 minus 1 is -0.75. So let's see if this works. -0.75 gets me to -0.50. -0.50 minus 0.75 is -1.25. And the next one is -2. So our change is -0.75. Okay. Now, the third one is a little tricky. So what are we going to do here? This is all data probability and analysis check. Watch this. The first thing we're going to do is do 80 minus 92. You always subtract or divide the number on the right by the number on the left. And then we want to divide this by the number of jumps. So to get from 92, we jump 1, 2, 3. We had 4 jumps. So if we divide this number by 4, we get 80 minus 92 is -12 divided by 4 gives us -3. So let's try -3 and see if it works. 92 minus 3 is 89. Minus 3 is 86. Minus 3 is 83. Minus 3 is 80. That works. So this was a range average problem. I took the range, the difference in the highest and the lowest number, and I divided by the amount of jumps. A sequence starts with 1 and 10. Find the next 2 terms of arithmetic. So as soon as you see arithmetic, you know plus, minus. 1 plus 9 is 10, so this has got to be 19 and 27, 28. Find the next geometric means multiply or divide. So 1 times 10 is 10, times 10 is 100, times 10 is 1,000. And the next 2 possible terms, if it's neither. So you can write anything. You write 1, 10, you can write 11, you can write 56. Doesn't matter what you write for your next terms, as long as you don't have the same number operating on each term. Complete each geometric sequence when with missing terms, and then find the factor. So let's see, 5 times 5 is 25. So if I divide by 5, I get 1. 25 times 5 is 125. 125 times 5 is 625. So the growth factor is times 5. 1 times -6 is +6 times -6 is -36 times -6 times -6 is -1296. So this would be times -6, or just write it in parentheses, whatever. 10 divided by 2 is 5. Divided by 2 is 2.5. Divided by 2 is 1.25. Divided by 2. So it's divide by 2 or multiply by 1/2. I want you guys to get used to seeing division and multiplication as the same thing. Okay, now 36. So -108 divided by 36 is -3. So this is times -3. So if we're going to the left, we're dividing by -3. So -12 divided by -3 is +4. -108 times -3 is 324. So you got positive, negative, positive, negative, positive. That's how it goes. Whenever you see the sign switch from between each term, you know you're multiplying by negative. 12, 18, 27. 12 plus 6 is 18. 18 plus 6 is 24. That doesn't work. 18 divided by 12 is 1.5. What's 18 times 1.5? And I'm doing this on a calculator off screen so y'all can't see. That gives me 27. Oh, look at that. So I'm multiplying by 1.5. And so now, going to the right is multiplication. Going to the left, you divide 12 by 1.5 and you get 8 and you get 40.5. That's 40.5 on that one. Okay, choose a growth factor and list the next three geometric. Multiply and divide. So 4 times 2, let's do times 2, is 8 times 2 is 16, and times 2 is 32. When they give you the first term, write that down, and then when they say add 3 more terms, I want to see a total of 4 terms. I don't just want you to see you put 3 terms down. I want to see you write the first term first. All right, give a different growth factor and list the next 3 terms. So growth factor. Growth factor is geometric. That's the change in the geometric sequence. So 4 times 3. 4 times 3 is 12. Times 3 is 36. 36 times 3 is 108. 108 times 3. Oh, that's good enough. That's only 3 terms. Okay. Okay, so here is a rule that can be used to build a sequence of numbers once a starting number is chosen. Each number is 2 times 3 less than the previous. All right, this is tricky. So 3 less than the previous number. So we said before that the 3 less than is n minus 3, but the 2 times. So it's the whole thing times 2. So 0 minus 3 is minus 3. So that gets us to minus 6. So negative 6 minus 3 is negative 9 times 2 is negative 18. Negative 18 minus 3 is what? Negative 21 times 2 is negative 42. And then 42 minus 3 is negative 45 times 2 is negative 90. Woo, I had to erase that a couple times. I messed that up a couple times. All right, starting with the 3. So if I do 3, 3 minus 3 is 0 times 2 is 0. And then if I start at 0, it's the same numbers. Negative 6, negative 18, and negative 42. Okay. Can you choose a starting point so that the first 5 numbers a second are all positive? I tried 5. So wait, we started with 3 and everything went negative. Let's start with 4. 4 minus 3 is 1. So 4 would be the lowest number you could go because 4 minus 3 is positive. 4, if I start with 4, then 4 minus 3 is 1. 2 times 1 is 2. Ooh, that's going to be negative. That doesn't work. 4 didn't work. 5. 5 minus 3 is 2. 2 times 2 is 4. If I start with 5, 5 minus 3 is 2. 2 times 2 is 4. 4 minus 3 is 1. Oh, that doesn't work because 1 gives me negative. So let's go to 6. Sometimes you got to make mistakes. 6 minus 3 is 3. 2 times 3 is 6. So the lowest number we could start with is 6. That was tricky.